Hello, my name's Clyde Morris and I want to talk to you today about the inverting amplifier. Typically there's two things that we want to find out about the inverting amplifier, and those two things that we usually want to find out are the voltage gain, and the other thing that we usually want to find out about the inverting amplifier is to calculate the output voltage. Okay, so let's go with calculating the voltage gain first of all. There's a formula which allows us to calculate the voltage gain, and this is the formula here. And the voltage gain is given by this formula, which is minus RF over R in. And if we look at the diagram, we can see that RF is equal to 10K and R in is equal to 2K. So I'm just going to put those two values into the formula. Okay, so just substituting in, we've got the gain is equal to minus, we mustn't forget the minus sign, 10K over 2K. K of course is 1,000. And when we work that out, the K's will cancel and you'll get 10 divided by 2, which will give us minus 5. Okay, so the gain is equal to minus 5. Notice that the gain is just a number. In this particular case, minus 5. There are no units for voltage gain. It's just a number. Okay, so we've done that. Let's go to the next part of the problem. And the next part of the problem is to calculate the output voltage, V out. Okay, so we just need to substitute into this formula. V out is equal to gain times V in. And when we substitute into that, well, we already know what the gain is. It's minus 5. We know, looking at the diagram, what the input voltage is. If we just go back up here, the input voltage is 1.5 volts. Okay, so we just need to substitute that in here, and that is 1.5 volts. Okay, and when we work that all out, we find that the output voltage, V out, is equal to minus 7.5 volts. Okay, so we've calculated everything that we've been asked to do. We've calculated the voltage gain, and that was minus 5, and we've calculated the output voltage, and we got the output voltage to be minus 7.5 volts. Okay, so let's just do a quick summary of what these results mean. Okay, so yep, we just do a summary. And I'm just going to draw a little diagram to summarize what we've got. Okay, so I won't draw the amplifier again, I'll just draw it as a box. So we had an input of plus 1.5 volts, that's what was going in, and we ended up with an output of minus 7.5 volts. Okay, so this was the output for a given input of 1.5 volts. Okay, so what's this summary telling us? Well, there's two important points. The first point is about the polarity of the two inputs. Okay, so let's have a look. So as far as the input is concerned, V in is plus 1.5 volts, okay? And when we did the calculation, this resulted in an output, V out, equal to minus 7.5 volts. Okay, so what's going on here with this being at 1.5 volts and the output being at minus 7.5 volts? Well, the first thing that you can notice is that the output, V out, is inverted with respect to the input. In other words, the output is negative, but the input is positive. So what we can say is the output V out is inverted with respect to the input. Okay, and what we mean by that is that V out is negative, but V in is positive. Okay, and this is a characteristic of an inverting amplifier. You know, the clue is in the name, so maybe it shouldn't be any surprise that the output is negative, whereas the input is positive. Okay, so it's an inverting amplifier, and this is what an inverting amplifier does. If you put in a positive voltage, you get a negative voltage out, or alternatively, if you put in a negative voltage, you'll get a positive voltage out. The output is inverted with respect to the input. So that's the first important point. Okay, what's the second important summary point? Okay, so I'll just quickly sketch this again so we can talk about the second point. All right, so we've got plus 1.5 for V in, and the output is minus 7.5 volts. This is the V out. Okay, so what's the second summary point? Well, what we can do is we can look at the absolute value of the input and output. And what I mean by absolute value is the size of the input and output regardless of sign. So the way we write absolute value is like this. So V in, the absolute value of V in would be 1.5 volts. Okay, so that's the absolute value of V in. And the absolute value of V out is equal to 7.5 volts. Okay, absolute value is the value regardless of the sign, and that's why I've put these parallel lines, just looking at the value regardless of the sign. And it should be clear that the output, its absolute value, is bigger than the input. So we can see that V out, the absolute value of V out is greater than, okay, is greater than the absolute value of V in. Okay, so this is the other takeaway from this. And of course, you know, it's an amplifier, so it will make V out, it will make the absolute value of V out bigger than V in. And, you know, if we look at the formula which we use to work out V out is equal to the gain. Again, I think I'll write this as the absolute value, the gain times V in. This is the formula that we used earlier on. And the absolute value of the gain is 5. That's to say the value of it ignoring the sign. So what this means is that the output is 5 times bigger than the input. Okay, so V out is 5 times bigger than V in. Okay. So this is the second takeaway. So the two takeaways, just in summary, is that the output is inverted with respect to the input. And the other takeaway is that the absolute value of V out is greater than the absolute value of V in. Another way of saying this is V out is amplified okay, V out is amplified with respect to V in. Okay, V out is bigger than V in. It's amplified by a factor of 5. Okay, well, thanks very much for watching. I hope you found that useful.